Good morning, everybody, and welcome to our second IAFA event focused on 6G standardization requirements. It's the second of a series of 3 events. As you know, you might have attended our first one. It was called First Steps. 6G standardization requirement. This is Interim Steps, and we're going to dive a bit more deeply into a couple of technical matters, plus we also have the pleasure to host a couple of projects linked to 5G and 6 and 5G and beyond, so both from the 5G PPP and the SNS Geo initiatives. Okay, so as you know, the session is being recorded. I hope you're all fine with this, and the video will be published on the YouTube channels of the SNS Ops project and HSbooster. I should also add that this is a series of events organized in partnership with HSbooster. As we said, SNS Ops obviously is the main organizer through the IAFA events series, and then SC is also there supporting. Okay, this is once again me. So I'm Claudio. I'm from Trust IT, and we are the main organizers of the event, considering that we are involved in both projects. And both SNS Ops and HSbooster, 2 projects that are supporting this events of pre-standardization. So about the agenda, we're gonna have as the next presenter Jessica Carneiro, project manager at Australo, and also the chair of Network Europe. We're gonna talk about the role of SMEs in shaping standards, with a particular focus, obviously, on the 5G, 6G community. We then have insights from different SM projects from the, not only, I should say, the SNS community, but also GPP, and these are Predict 6G, 5G Epicenter, and In5Gent. And then we have 2 sessions which are more interactive with our experts from HSbooster, who also were present in the previous discussion. And these are Muslim Eltop, whose presentation is entitled Matchmaking During Transition, Moving from 5G to 6G, How We Can Synergize Major R&D Outputs with Standardization Work Streams, and Tasos Dajuglas with the presentation entitled A-Native 6G Architectures, Research Challenges and SDO Opportunities. Okay, both sessions will have short interactive sessions with audience, which will also be helpful to break the ice a bit and to kickstart more interesting discussions, and to also understand and package all the learnings that we will have today. Okay, without further ado, I would like to now give the floor to Jessica so we can start and amend for the delay that we are already on. Thank you, Jessica. The floor is yours. I will stop sharing.
Hello, good morning. I hope you can see my slides already. Just if you can confirm.
Yes, we see.
Yeah. Okay, so thank you, Claudio, for the presentation. I am Jessica Carneiro. I work for Australo, but I'm working there with Claudio in SNS Ops, among other things. And I also have the pleasure to be Network Europe SME Working Group Chair. So this presentation I'm bringing today is to showcase and share with you what's the current status of the SMEs in the work on standards. So for those of you who might not be familiar, Network Europe is the European technology platform for communication networks and services. And the SME working group is one of the 4 working groups attached to Network Europe. In this case, as the name already explains itself, our members are mainly SMEs in the telecommunications sector across Europe and some 3rd countries as well. The main mandate of the working group is to provide a voice for the SMEs in the sector, ensure their interest. We also monitor the SME participation in different projects or initiatives, such as the SNSJU, and we help and support SMEs, for instance, improving their visibility in the whole ecosystem. For those of you who are here today and you are an SME, just for you to know that you can join for free, very quick registration, and we will provide you support at any time. In a snapshot, you can see here in this slide the composition of the SME working group. So, of course, SMEs are the majority by far, with almost 90% of the whole members. But we also have plenty of research institutes / universities, and we have some larger industry and association, which is JIE, 6GIE, sorry. And in the map on your right, you can see the distribution. So Spain and Greece are the countries where more SMEs belong to the SME working group. Also, Italy has quite a high number. But definitely Spain and Greece top the ranking with the most SMEs. And now into today's topic. This was, I would like to say that this was a very interesting exercise when I was asked to participate today here, because the SME working group has not worked on standards so far. It's not a topic we have discussed. So it was a great opportunity to actually bring this up and to understand what's the status quo in the working group. So what is happening there? For this, we launched a short questionnaire to collect information on the SME's position in standardization. It was very basic. It only had 15 questions that collected some basic information, the SME work on standards, their participation in SDOs, and then some additional questions regarding their use of available support in different initiatives and programs, their insights regarding the trends that have been collected, and so on and so forth. So we didn't have a high rate of answers, but I think it's a good sample to see what might be the perspective and the actual situation of the SMEs when it comes to standards. So first of all, SMEs were asked to categorize themselves in the ecosystem, so as provider, users, or enablers. And by far, most of them were consider themselves enablers or facilitators in the ecosystem. But nonetheless, we also had some providers and some users. As per the first question, out of the whole SMEs that were asked or that responded, only 36%, and that's 5 SMEs, indicated that they were involved in standards to some extent. So what was mentioned? So as you can see here, participation in GSMA, OPG, ETSI Software Development Group, and the Open AR Cloud Association, the Italian UNINFO, I'm not sure about the pronunciation, and Sensenelec. Sensenelec actually was mentioned by 2 SMEs, although in different areas. And here I added a question for all of you, and if some of you are SMEs, and I would like to know if you also are working on standards, and if so, how? So I think Claudio can show you how to answer to this question.
So I sent you a link in the chat. Please check that link. And this goes to a Mentimeter, which will then contain this question, this first question. Browse this page and go to answer the first question. I'm also leaving the code in the chat once again, in case it doesn't open automatically. I would give a couple of minutes for people to join the Menti polls and give their vote, and then I'll project my screen. We can comment a bit on the answers that we received.
Okay, so maybe I can continue while people answer. I would be very curious to know what's your situation. Then the second question was related to the work on standards, but instead of being directly led by the SMEs, done through European research and innovation projects, such as the ones that we have here presenting a little bit later today. So again, 36 of the SMEs partake in some European R&I project addressing standards. Of those, the 22% are really involved in this work, but 14% are just part of the project, but not really involved in any work with standards. So there is quite a division. And the projects mentioned were 6G for society, although the activities have not started yet, and 6G musical, where they follow cases in 3GPP. And then it was also mentioned the E2T focus group on environmental efficiency, although in this case, no specific project was attached to this contribution. As it might not be a surprise as of now, most of the SMEs are not involved in SDOs, and those that are involved mention the following SDOs. So ETSI, IEEE, GSMA, Camera, Sensenelec, and 3GPP, ITUR, WRC, and UNIFOM. Then we asked about some trends that were identified in SNS Ops deliverable for 4.2 that was submitted last month. And as you can see here, there is quite division of opinions among the SMEs. So the three most popular trends are the development of high-capacity, low-latency communication solutions. So this is kind of by far the most popular. Then followed by AI in network management and security and user-centric network designs. SMEs also indicated sustainability and energy efficiency in network operations as some trend that applies to them. Then 80% responded that none of the above. No SMEs indicated the trends, convergence of terrestrial and non-terrestrial networks and advancements in radio access networks that were included in the menu or in the list predefined. And on top of that, they mentioned XR and VR digital twins as that were not included in the list. Finally, we decided to ask them if they are aware and if they use the different available support through various initiatives, programs, instruments, platforms in the EU. And not quite surprising, only one SME reported to have used some of these tools. It was the sorry, the Stan ICT, and the experience was described as good. One other SME used the standards tracker provided by the SNS JU. And here there is my second question on which are some tools and activities or just overall support that we could offer to help your organization working in standardization. As you can see, the conclusion from this small sample, although I guess it could be quite indicative, and this is the reason that also not many SMEs might have answered, is that they are not really working in standardization at the moment. And this is an important conclusion we might draw from the questionnaire. So the next steps for us will be to understand why, what are the reasons it is that standardization is just not something that interests more of the SMEs? Is it that they just lack maybe the knowledge or the support to really work on this? And therefore, we will definitely have a follow-up to today's presentation to try to gain better understanding of this. So maybe I will just show my last slide and we can see if we have some answers in the Mentimeter.
So let's do like that. Thank you, Jessie.
So just a bit of, again, for those of you who might not be familiar, you can check the website for the SME unit and the brochure that was released in February, and as well as follow us in the social networks, especially if today you heard something that it was of your interest, maybe you can keep following us. And now I will just stop sharing so Claudio can share his screen and let's see.
Yes.
If we have.
So I sent you once again the link to the polls. So please click on this link and vote, express your vote. I'm sharing now my screen about the first question Jessica had for us, which is, are you an SME involved in standards? If so, how? As you can see, I mean, I think the replies, in a way, they are expected in terms of what they tell us. I don't know if you want to comment on that, but I think, as we said before, again, not a direct involvement, but a lot of work in terms of facilitation and implement, which we could take almost as synonyms in this sense. Roadmaps, I mean, it's more policy oriented, but it's almost on that sense as well. And there is a no, there is a big no, as you can see.
Yes, I fully agree that maybe this was what we could expect. So I think it's really maybe figuring out these first steps and how to facilitate that SMEs enter into this domain. But I'm happy to hear if somebody from the audience could like to add something about this or about something you heard in my presentation, or if you have any question.
Yes, I would say perhaps let's look at the next question and then we see if there are any questions from the audience about that. Okay, so the second question says, which are some tools, activities, and overall support that the SNSGU could offer to help your organization work in standardization? Please vote through the link that I sent you. I will send it once again in the chat for you to peruse and to be sure that you can contribute. Don't be shy. Meanwhile, Muslim as a question.
As a actually a comment, just a comment to add to what Jessica was saying. So I think it's great to have, let's say, like a working group to support SMEs. I think that, Jessica, what would be maybe helpful is to to see more clearly for SMEs that are interested in doing more in standards, to see how you can maybe support the of, let's say, building a bridge towards certain SDOs, like HC, ITU, and so that they can see what kind of support can they get, because it starts always with the first, let's say, contact point. Which SDOs can you work with? Which working group do you, say, knock at the door? And then this can, because some of them don't even know that there are opportunities. Some SMEs don't know that there is a working group, for example, in ISO or which is doing this, which they could need. And also, I think you have a lot of expertise in your working group, also at Australo, to maybe help SMEs identify what can be standardized. So some of them need a small push, and I think that there's a lot that of value that you can add here. Maybe this could be a topic for a subsequent later session here. That was wanted to add to your presentation.
Thank you, Muslim. I fully agree. I think maybe a big obstacle is the fact that there is maybe lack of knowledge or familiarity, and the standardization is highly complex at the beginning if you've never done that. And if you haven't had the chance to get acquainted with some bodies, some working groups, how the work functions. So trying to raise awareness about this will be one of the first steps to take in the near future. Thanks a lot.
Yes, that's why I once again link to vote in the chat. Please do so if you wish to contribute. I will share my screen once again so that we can see the first responses coming in. Yeah, so yeah, again, it's predictably what we thought, what we were saying. So I think we have a glance of what's going on in terms of the landscape. So further learning material once again, more facilitation. So again, all points that we discussed before. So there is a need in order to SMEs to participate. It seems that there is a need for more materials that can provide guidelines, right, for that.
Indeed. So thank you very much, because this has been actually sort of validating as well what we had found out in the questionnaire. And I also think it gives us a lot of food for thought for the coming months, and how we can actually bring these elements to SMEs. Thank you very much.
Exactly. The SNS program will need to also think about that and to consider potential ways to bridge these gaps. We will package all the learnings into a report, by the way, which will be presented and also sent to the SNS office so that they will know how to take it from there. Okay, without further ado, because we are 10 minutes late, I would welcome Carlos Bernardos, Thanasis Caremes, and Luis Miguel Contreras from Predict 6G, 5G Epicenter, and InFiveGent, respectively. We're going to provide us with some insights from them and their experience with that. So I will give the floor first to Carlos, and then Thanasis and Luis Miguel can follow up. Thank you.
Okay. Hi. Thanks for the introduction. I hope you see me well. Let me share my presentation.
Yes, we can hear you and see you. Thank you, Carlos.
Okay, perfect. So I will try to be brief, and because we are a bit behind schedule. So my name is Carlos Bernardos, and I'm presenting this work on extension to wireless deterministic networking, to wireless NetNet, that has been done mainly through the Predict 6G project and the 6G data-driven Unicode project in Spain. So the outline, although I will go very quickly through some parts, is the following. First, introduction on what is deterministic networking, what we aim at getting. Then a bit more like close to an application that we can understand a scenario for explaining what or why deterministic networkings are important. Then I will go into what an SDO that is very relevant in this area, but not the only one, ITF, is doing in this arena about what is deterministic networking. And then at the end, I will briefly touch upon on three gaps or areas that PREDICT-C is extending and tackling in terms of wireless deterministic networking extensions. And then some conclusions at the end, mainly listing the contributions that we have done to the IETF and the status of those contributions. So regarding the introduction, deterministic communications basically try to ensure that we are capable of providing or transporting the packets, the right packet at the right time, basically ensuring that we have a deterministic data delivery latency that is bounded, and that we can ensure that also the jitter is bounded, so we can have the packet delivered at the specific time without loss, and of course, and with a minimum delay due to congestion or errors. Deterministic communications can be tackled at different layers of the protocol stack, layer 2, layer 3, and layer 2. The main player is IEEE with all the IO2.1 extensions on the time-sensitive networking, and at TSN. And in layer 3 and above, the IETF has been a key player with all the work that the DET networking group has been doing, and also the RAW working group, as we will see later. Then the IETF working group is the working group in the Internet Engineering Task Force that is devoted to deterministic networking. Initially, it was working only on generic aspects and wired technologies. Then there was a kind of sister working group that was called RAW, Reliable Available Wireless, that started looking into the specifics of the wireless deterministic networking, and then very recently they merged again. So now all the wireless and wire work is being done in the DETNet working group alone. There are some description there about what it's doing and the link about the working group that is open for anybody to contribute, as the IETF is. You can see all the details there. Then an exemplary use case very, very quickly is the industrial wireless for industrial applications. So we can see a factory, for example, where we can deploy different machines to operate that typically may involve mobile parts and that they require communications. As of today, many of those are using proprietary solutions, but the idea will be to move to wireless generic or not proprietary solutions like Wi-Fi or 3GPP type of networks. And in these cases, we have different types of requirements. We have, for example, PLCs to control some machinery with feedback loops that require very low latency and very high reliability, where DETNet should get in. But we also may have some additional monitoring traffic, for example, that is more like best effort kind of thing, and both they have to coexist on the same deployment. So the idea is that DETNet solutions should not only provide the warranties for those flows that require warranties, but also coexist with other flows that may not have those strict requirements. Then to get into this picture and try to provide solutions, we have the DETNet and RAW working groups, and the RAW, the Reliable Available Wireless, which we can consider as the wireless DETNet part, basically specify an overall conceptual model where we have different nodes for wireless, nodes that are involved in a communication between one entry point and another entry point. The entry points may be connected through one ingress node and one egress node. And we have a control plane part that is capable or is responsible of controlling how the forwarders, the raw nodes, forward the traffic and what operations they do in order to guarantee the latency and reliability requirements of the traffic. So that this is basically developed and explained in a working group document, which is called draft IETF. Well, now it's called draft IETF DETNet RAW architecture because of this recent merge, and it's still being developed, but very close to the finalization of this document and publication as a standard in an RFC. Then the way RAW and DETNet will coexist, basically, well, the way one of these ingress nodes or relays nodes are logically structured is the one that I show in the picture very quickly because we don't have time to go into details. We have on the one hand OAM, so operation administration and maintenance or monitoring of the status of the network. Then we have some operations on the networks, on the packets in order to guarantee the requirements. So we may do, for example, the application of some packets through different paths when we have multiple potential paths to be used to guarantee the characteristics of the traffic. And then we have one entity which is called the path selection engine, that is the one deciding what to do and instructing the nodes what to do. This entity may be logically centralized or distributed among all the different relay nodes. With that in mind, some very quick summary of some of the challenges that are being tackled. One is multi-domain. The DET networking group initially thought of considering single domains and described the architecture and operations within one single administrative domain, but it's very clear that we may have multiple administrative domains and also technological domains. So for example, OIM mechanisms are defined for single domains. The entities, these control entities, these PSCs that I mentioned before, are meant or are initially specified as entities to operate in a single domain. So when we have multiple domains, we have to interoperate, intercoordinate these entities to facilitate multi-domain end-to-end deterministic communications. So this is one of the things that we have specific contributions from the Predis6C and CC data-driven project. Another thing that is relevant is the integration of edge deployments, so multi-access deployment, HCMEC deployments, and RAW, because in the edge platform, we may have a consumer of an application that is deployed in a MEC, in an edge, but the connection between the application, the consumer, the device consuming the application, and the MEC where this is instantiated may be a RAW capable, a DET wireless capable network, and we need to basically integrate those things so the MEC is aware of the capabilities of the RAW network and can extract certain operations and the other way around. And that's what we try to summarize in this slide, where we provide or we propose some logical entities to be deployed in the edge that interact with the RAW network in order to facilitate all these aspects, extending one interface defined by ETSI, which is MP2, that is identified by ETSI but not fully specified by HCMEC. So we can do this type of extensions. And last but not least, mobility. Very quickly and very simply, when we have this type of scenarios and communications, as of today, they are considering static scenarios where the nodes, the end nodes do not move, and also the nodes in the network do not move. But since we have wireless scenarios, it may be possible that both the endpoints and the network nodes may be mobile, and this requires again coordination between the control entities in order to predict and prepare in advance to a potential handover scenario. So this is another thing that we are working on. And last, just to summarize the different contributions that we have done from these projects to the ITF, I'm highlighting in this blue box the ones that have been adopted. Some of them are even published already as RFCs, and the ones that are adopted by the working group and are still being developed towards the final publication, plus some others that are still being discussed within the working group. And with that, I finalize. So I hope I made it more or less in the allocated time. So if you have any questions, I will appreciate it. Thanks.
Thank you, Carlos, for this very interesting presentation, which is actually a success story in a way. Some of the points that we tried to discuss here of integration of frameworks already existing and apply them in certain contexts. So very interesting. Thank you a lot for this. I would give the floor now to Thanasis from 5G Epicenter. Thank you.
Thank you very much. Give me a second to share my screen.
Go ahead.
I hope you can all see my screen. First of all, thank you for the invitation.
No, we cannot see.
Not yet.
We cannot see them. No.
Now?
Still not.
Still not. Why this happens? Now?
Oh, it seems that something is wrong. What you could do, you can send it to me I'll send you my email in private. Maybe I give the floor first to Luis Miguel then, and then we try to solve this issue.
If possible, actually, as I can see, there is it's a trial to go for connection. Sorry for this, probably, but internet. If you can want to proceed, please proceed with the other presentation.
Yeah, we'll give the floor to first Luis Miguel.
Send
If
you the
you're there.
presentation as
Yes,
well.
please
Thank you.
go ahead, and then I'll send you in private my email. Okay, so you can send it there, and then I can share for you. Well, please go ahead, Luis Miguel from In5Gent. Hello.
Hello, everybody. I will try to share my screen. Let's see if I don't experience the same issues. Can you see my screen now? I guess yes, right? Okay.
Yes, it's starting to share. Should work.
Perfect. Give me just 1 second to remove the different windows that the WebEx generates. And okay, so I will go then. Okay, so this is Luis Contreras from Telefónica. I will present the view from In5Gent, not only presenting, let's say, what we did, but also somehow the approach that we follow for all this approach to standardization. So it's somehow commenting about the journey as well. So I will set up the pointer. Just 1 second, please. Okay. So what is the key purpose of standardization, at least in our approach to the standardization? So basically, the objective, one of the main objectives would be to facilitate the interoperability. So for whatever technical solution we will have a number of different implementations. So it's essentially to guarantee that the functional behavior of the different solutions is similar in the sense of accomplishing the same kind of features, the same kind of functionalities, and then the behavior. So through standardization, we try to address that the different solutions, the different implementations behave in the same way. Also, it's a mechanism, a way of ensuring the feasibility of the different technical alternatives. So again, from different perspectives, the different implementators will approach the same problem. So we need to ensure that somehow they accomplish, let's say, the mission of the solution in the same way. Also, through standardization, we can identify common procedures and the same inputs and outputs. This is important as well in order that expecting the same behavior again. So in some cases, it's not just a matter of what the system should do, but also how the system should react in case that some event is not expected, right? And then standardization allows the coexistence of these different implementations conform to the standard specifications. So that is why it's important to have these kind of specifications with the different requirements explicitly, let's say, addressed properly. And also finally reduce the entropy in the industry so that we can focus on well-adopted solutions. So somehow orienting all the industry on the same direction. So with this key purpose, the approach that we follow in In5Gent was the following one. So putting emphasis on operational aspects, this is key. So at least from operator perspective, for sure is key. So having this operational view end to end, which is difficult to tackle sometimes because of there is not just one single SDO that addresses all the complexity. And I will comment later on the approach in In5Gent was mostly on slicing, right? So different SDOs working on the same topic, but in a fragmented way because of the nature of the responsibility of each SDO. So we put emphasis on having this operational aspect end to end, so covering all the provision of the service, in this case, the service of slicing, network slicing. We also, for that purpose, we exercise the different standard propositions against use cases, the use cases defined in the project that help us to identify the gaps and also to identify the potential solutions for those gaps. So in such a way that we can come back to the SDOs and providing feedback based on this exercise with the use cases and trying to cover those gaps already identified, right? And apart from that contribution to SDOs, we also move into industry-driven fora. So in such a way that we can close the loop and provide requirements in terms of product requirements and specifications. And I will mention later on what was the kind of forum that we addressed. That was essentially the telecom infra project. So basically and graphically, we departed from the operational use cases. We exercised the life cycle execution with existing SDO specifications. With that, we identified the gaps in the standards, providing feedback on one hand, so providing feedback to the SDOs, and then also providing inputs to different specs in such a in the form of requirements, so in such a way that also we try to transfer to the industry the way to follow. So closing the loop from the conceptualization of the service up to the realization of the service. So moving now, more focus on what we did exactly in 5G. So we addressed the problem of network slicing. Network slicing somehow do a conceptualization top-down. So with initial ideas from the GSMA, the network slice templates, and so then these network slice templates were processed or were taken by 3GPP, and 3GPP started to define the way of realizing these slices in the 3GPP concerns, that are basically radio access network and core network, but leaving apart, let's say, the transport capabilities. So in 5G, that was a transport-oriented project, took that kind of gap and start trying to exercise and fill in that gap with two of the major standardization bodies in the transport arena, ITF on one hand, and ONF, now moving to Linux Foundation in the other hand. For the ITF, we concentrated on the technology agnostic JAM models that are being defined in the TIS working group. So basically, this idea of having a way of, in an agnostic manner, express the needs of a network slice. And in the case of ONF, we concentrated both in slices for optical networks through the TAPI, through the Transport API, and also in microwave networks with the specification of the TR532 for microwaves. So from that, and let me just to reinforce the message of this fragmentation that I was mentioned before. So looking into the case of slicing, as said, there is not a unique SDO addressing that fact, right? Here we have simplified the figure before, so we are removing, for instance, GSMA or ONF, but just putting into the context, at the time of defining a slice end-to-end, we need to cover different SDOs. 3GPP as main SDO for defining the network slice in mobile networks. Sorry, the O-RAN Alliance at the time of defining how the slice is realized in the context of radio functional split. That was one of the target as well of the project. ETSI, in the case of dealing with virtualization, so there are different ways, different manners. We have the cloud native way with Kubernetes. We have the classical, let's say, NFV way with ETSI, or even the combination of both of Kubernetes and ETSI NFV even. And then in the case of ITF, for having this technology agnostic approach in such a way that we can consume transport network from that point on, and from that technology agnostic MBI, even realize the slices with IP technologies, microwave technologies, optical technologies, or a combination of all of them. So this is a clear example of this kind of fragmentation, let's say, natural, because of the responsibility of the different standardization bodies. A similar approach, similar view will be much more, let's say, intuitive in this representation of what is the responsibility of the different standardization bodies in the different segments of the network. So we need to address and we need to accomplish a slice end-to-end. So from the radio access, the very radio access, maybe with a radio functional split architecture, up to the access to the internet, so the UPF and beyond. So as you can see in this kind of map, different bodies address different parts or tackle different specific parts of the problem. So it's essential and basic, let's say, go and take the problem from this comprehensive view and trying to identify the different gaps. This is what we did we intend to do, and we did in the project. And consequence of that, we realized we released a number of contributions to different bodies, to ITF, to ETSI for the TerraFlow SDM project, the EPP, ORAN, and also ONF, now Linux Foundation, the activity being moved to Linux Foundation for the Transport API. Apart from this contribution to, let's say, natural SDOs, we also contributed to the Telecom Infra project, basically introducing requirements so that products could be compliant with, so in such a way that they can satisfy the need of the industrial need of network slicing in the next future. So this was basically the presentation. I will go just through a quick summary. Standardization is key for a rapid progress and adoption of technology advancements. This is clear, so we need to foster the adoption and we need to spread the adoption across the industry. We need to standardize the behaviors, the expected inputs and outputs from the system, so in such a way that we can have different implementations and that with that fostering, let's say, the adoption. There is a natural fragmentation in standardization activities. Each of the bodies has a particular responsibility. So this requires to have a joint work with all of them and experiment through realistic use cases so that we can fill the gaps and we can close the boundaries or let's say, identify the glue between the different bodies, so in such a way that we can later on have a smooth operation of the slices in this case, but any other solution in general. So apart from the standardization bodies that somehow we can leverage on them for defining the solution, another vehicle for fostering the adoption would be the industrial fora, like the Telecom Infra project in this case, so that can speed up the adoption in the industry. So moving towards the product side, let's say the requirements identified so far. And yeah, just to mention that the standard specifications permit different implementations to coexist to reach the market, because having different implementations, we have different experiences, different capabilities of address the same problem. And just to reinforce the message that a comprehensive approach, as we did in InfraGen, can facilitate the overall cycle. So from the technical inception of the service or product up to the real production and the real, let's say, transfer to the product at the end that implement the service on top of that. And that was all from my side. I added some additional backup, but I will not move for that unless you have questions. So, yeah.
Yes, thank you so much, Luis Miguel. I think this was very interesting, also with some policy insights at the end, which is really needed. This type of summary slide that sort of is essentially what policymakers look for in defining new policies. So this is really great insight. I will give the floor to Thanasis now, and then perhaps open up the floor if there are some brief questions. Also, feel free to ask your questions in the chat, okay, to our speakers so they can answer. Feel free to interact as much as you can. Please, Thanasis, the floor is yours now. You can share your slides.
Thank you very much, sir. Fine? No?
No, we cannot see it. Sorry. I sent you my email address on the chat. If you can send it there, then I can share for you.
I don't know why I'm not. Sorry. Give me. Give me 1 second to send it for me. Sorry for this.
Sorry
My
to interrupt,
apologies.
Thanasis. I think it's fine if
a
you can
network.
present also without slides, and then we'll send them as soon as possible. But at least
I can do it as well and provide it or upload it. Unfortunately,
I think you can present your experience,
uploading
quickly.
to the email I provided. Well,
No problem
let
with
me
the
be brief.
slides. I think you can just speak.
Well, yes, of course. I actually have the content in front of me, so let me make an introduction. The slides will be provided in order to be uploaded as well. Actually, let me here to present and talk about the 5G epicenter. For standardization, we had the opportunity and the chance to involve HSbooster in our activities and to get insights from the HSbooster extra on our activities. Just in brief, 5G epicenter is an end-to-end 5G experimentation platform. It is designed in order to work and be applied through testbeds so that, let's say, SMEs or relevant stakeholders for the PPDR community, the public safety and emergency response, actually industry or SMEs players that could have the opportunity and be able to verify and validate their solutions. So the project has been structured in, let's say, a pilot set of trials. We have 8, let's say, the demonstrations from SMEs that participate within the project. The project is characterized as 5G beyond from the 5G PPP. So we try to develop a full complete architecture in order to run experiments as a service. This is the platform business model and how it works in order to provide microservices to SMEs and network applications so that you can, let's say, repeat and leverage the power of 5G networks in shareable environments, federated and, let's say, heterogeneous in an automated way. In order to reduce time and cost, let's say, for testing 5G solutions. So this is the ideation of the platform. Dissemination, standardization, and exploitation is a big part, let's say, of our project that focuses in mainly 3 pillars. The first one is the federation of let's say, being able to integrate several 5G platforms, let's say, from the experience of previous projects, and be able to provide several microservices to the SMEs. The network is private. We have worked on visualization based on the definitions and the requirements of the standards, the zero-touch orchestration for controlling the platform, the significant applications, the network applications that are involved actually are designed and applied based on the definitions and the requirement standards from as defined by ETSI and 5G PP. So the platform is fully compliant with the existing standardization standards. And here I need to highlight the fact that 5G epicenter actually emphasizes on the deployment and commercialization of solutions for testing, let's say, these solutions. Plus, we also provide, let's say, full cloud solutions, since the architecture is based on Mano and Kubernetes deployment. And we also comply with several standards as well. In the project, we involve 4 main testbeds in order to run, let's say, all the deployments: the 5G Genesis in Malaga, the 5G Vini in Aveiro, the 5G CCTC in Barcelona, and the DHSI in Fraunhofer. As I said, we have several PPDR use cases from MCX mainly solutions run by our coordinator Airbus, using multi-agent and multi-deployment communications with service scaling. We involve the transfer of communications of, let's say, drones, and here I have use cases to showcase in collaboration with, let's say, this one in wearables and VR, VR and AR technologies as well, and precision mapping. So overall, on the standardization, the project has, let's say, provided several let's say, deployments. We do consider all the definitions and requirements aligned with the main organizations. Mainly, we follow ITU ETSI definitions and requirements for the involved, as well as 5G BBB definitions and information. The first major part was the MCPPT requirements that had to do with specifically the PPDR applications and solutions developed and tested, both in the pilot cases, and right now we are running our experimentation program to support them. We support Mano with both container-based and VM-based VNFs, so we use Kubernetes plugins in order to deal with one of the major challenges that has to do with heterogeneity. So we do involve the specific VNF standards for the architecture and from the release Fit 17 in this one. As a project, we are very active in working groups, more specifically in the pre-standardization and security of the 5G CPP, now 6 years, and the vision and societal challenges, as well as the TVM, where I participate for in the initiation of the 6 year, another project as well. And of course, some partners of the project are very active in the SMEs, let's say, working group. So we are very active in ETSI plug tests, and we collect all, let's say, the lessons learned from the deployments. Mainly, we validate the 5G components of the platform for the 5G core network that, let's say, have been tested, and the MCX solutions that accompany the project. And right now we're in the process of disseminating and communicating the results and the lessons learned to access the relevant SDOs, also through the activities of the working groups. What our experience showcases, let's say in brief, let's say from the 5G epicenter, the lessons are multiple. The heterogeneity for both the infrastructure or the software that is involved is one of the core issues that is a major challenge for SMEs, since different SMEs within the same let's say domain do use different technologies or software in order to support their solutions. So there is the need for specific alignments in this type of deployments in order to comply with the standards. Interoperability is one of those challenges that try to be resolved. The fact that and indeed SMEs need to be involved. The fact is something that we do notice is that let's say solutions that are commercial from behalf of SMEs do tend to follow let's say the previous generation G networks, for example the 4G and beyond. There are solutions that have been commercialized so far, while in the 5G still let's say the most SMEs that show advancement and involvement within the standardization processes do tend to have, let's say, the demos of our box for deployment, but haven't been commercialized yet. So there is, let's say, a gap between these two. And I think that these were the main, let's say, lessons. I did have a pretty much good use case to showcase from a collaboration that we had from the 5G Epicenter with another project, the 5G CASP, about a successful deployment that took place a few months ago.
Okay, thank you, Thanasis. Thank you very much for your presentation.
Recorded it.
Okay, thank you, Thanasis. Thank you very much for your presentation. Just as a matter of an internal discussion, FYI, the slides will be circulated ex post, okay? We'll ask Thanasis to send them to us, and so we will post them in the event page as we have done previously. Without further ado, I would like to give now the floor to Muslim, one of the two experts who are today present to share their expertise in standardization. The Muslim presentation is entitled "Matchmaking During Transition, Moving from 5G to 6G. How we can synergize major R&D outputs with standardization work streams." The floor is yours, Muslim. Thank you so much for joining us.
Thank you very much, Claudio. And let me just start to go to full screen mode. Yeah, I think you can all see my screen. So welcome to my presentation. As Claudio said, I'm going to talk about matchmaking transition. So as we move from 5G to 6G, how can we synergize the R&D community outputs and work that they do with the work streams and standards and the whole complex landscape of standardization. So today we're going to cover a small recap in 2 slides from the last session, which is the 5G to 6G transition. Then we're going to look at, to simplify the complex landscape, we're going to look at some what we call R&D megatrends examples, just examples. So one of them is AI and machine learning. One is automation. One is architectural evolution, and then softwareization. And then we're going to look at the SDO or Standards Development Organizations landscape, also megatrends and work streams that they have. Also another type of grouping. It includes the above megatrends from the R&D community, and also in addition, some which are security and privacy, sustainability, and green communications. And then I'm going to give a small example how you can bridge these 2 gaps between the community of R&D and community of SDOs and standards through these 2 complex landscapes. So going straight into it, this is a recap of the last session that we had. We talked about how, let's say, the whole technology community moved from 5G, starting with new radio, which was only on the RAN part, moved to standalone 5G with the softwareization of the core of end-to-end slicing, service-based architecture, and then all the way to 6G, where you have precise let's say communication tailored to different let's say use cases, even the slices and verticals. And yeah, this was, I mean, it's all recorded, so it's part of the last session. Of course, you know, the complexity of use case that you can handle with the 5G standalone or 6G is larger than what you could do with the 4G or 5G new radio. And also we talked about last time that as we move to 6G, there is this strong tendency to have native by design features in the underlay. So you have, like, if you want integrated by design security enablement in 6G in the underlay part, so in the lower part of the software stack, you have basic AI mechanisms, just very basic. You have resource management, etc. And then you have the complex parts on the upper part, the overlay, which includes things like orchestration, user workflow. You have high levels of autonomy and automation as defined by TM Forum, which are level 4, level 5 AN, and advanced AI, which affects your use case workflow. This is just a 1.5 minute recap of the last session, which you can again listen to if you want. So now today's core subject. So what is the thinking behind that I had? So we have a very complex landscape of research R&D, great work going on, and we have a complex, let's say, set of SDOs, you know, ETSI, 3GP, ITU, you name them. We've seen examples already today. And how do you match people on both sides? How do you match work on both sides so they can really complement each other? This is the challenge that we actually face. So the idea is to group, first of all, the work streams on both sides into what we call megatrends, or like hyper trends, which are, let's say, main standing out patterns. So I chose here a couple of examples. One of them is AI and machine learning. Those are in the R&D community. They are, of course, data intensive. So AI is data hungry. So you have a lot of data processing, analytics, big data. It's also, this trend is also context aware. So you are building, let's say, semantic knowledge about the context of your environment. It's computation intensive because of the mass amount of data, of course. And you can enable through this, say, access to data and to using machine learning and AI techniques, new powerful whole range of new use cases, business cases, which are then, of course, subject of the R&D output. The megatrend automation. It involves autonomics, meaning that automating the behavior of your use case. You automate also processes that you have, your workflow, which is primarily your customer process that you are working with, and also autonomous networks. If you think of any kind of network underneath, microcell, picocell, closed network, private network. And then the megatrend architectural evolution, what does it involve? It involves, of course, as we just mentioned, the move from 5G new radio to 5G standalone with a software-based core, end-to-end slicing, and then to 6G. You have evolution in architectural dimensions that you have open ecosystems like Open RAN. It's still a hype, and we're still waiting for, let's say, more results to come out of that. It's taking a bit longer. Cloud-based RAN, you orchestrate your RAN and other resources which are scarce out of the cloud. And open ecosystem in general, where you can include different software vendors, different players in masses where you put in best-in-class players for each purpose. Of course, architectures are becoming more high precision. This is the demand from industry and high performance. And you have, as I just mentioned, native features coming in, especially under the overlay model. In the underlay part, you're having native security, native basic AI, native automation, which is, let's say, part of the 6G promise. And of course, softwareization includes open ecosystems. So you have not one vendor of software as an integrator, but you have lots of software players which are independent software vendors putting in their algorithms into the ecosystem. You have different operators which are in the ecosystem, and all what they do is based on software. It's software run, just like Open RAN as an example. Okay, so we take the first megatrend, AI and machine learning, from the R&D community perspective. So what are some sub-trends in this respect? There is one which is predictive analytics. So you're leveraging AI to predict things like, for example, failures in the network or anomalies, congestion or resource bottlenecks. How do you enable, let's say, through AI, through prediction, to guide the system to do or to take some proactive measures, and to automate things like, for example, resource management until it becomes in 6G a fully underlay integrated, let's say, feature. Then you have things like network slicing and optimization. So end-to-end allocating of resources, of course, dynamically using ML, because the requirements are changing. So in your use case, application services, there are different demands on resources. How to dynamically adjust these and block them end-to-end to guarantee or to assure that your service is running fully compliantly. To maintain, of course, quality of service, quality of experience, adaptively and efficiently, based on how much resource you have. And then, of course, you have AI-driven security, which is very interesting. So you implement AI algorithms that are analyzing patterns, and they are mitigating proactively certain or alleviating certain threats in real time. So this is like if you are like one step ahead using prediction, using AI, you can then, let's say, take out threats before they occur in full scale. Okay. The megatrend automation, it groups many things, but underneath you have mainly things like, for example, self-healing networks. So when you are able to, let's say, analyze certain situation which you can detect with high accuracy what is happening, then you can really find the remedy to that. So you adjust some links, some topologies, some routing. You can let's say make your network self-healing so it can patch itself or reroute and adjust certain things there. Of course, automation can go a long way until you reach zero-touch operations, but this is a bit ambitious and it's just partially available. You also have self-organizing networks, so networks that can dynamically compose and organize themselves, like among small cells that can organize into, let's say, fully working coordinated mesh, for example. You have dynamic spectrum management because RAN and the air interface is the most scarce resource that we have even today. So that's why you manage spectrum dynamically in an automated way. It should be all integrated in the chips and the logic of the RAN part, and also today in software as well. So you can, let's say, use your scarce, expensive spectrum in real time and enhance the capacity and performance of your network. Of course, reducing interference because you're on the air interface. And energy efficiency, very important. Automation can be used very effectively to control, minimize consumption of energy, and let's say to work towards stability goals. Okay. Architecture evolution. There are many things under this thing that have been ongoing. But you have structural transformation of the architecture. So, like I said, for example, 6G is more like polarized with underlay overlay. Underlay is becoming more with built-in native features. You also have a shift that you're becoming more, let's say, smart on the edge part. Some people call it fat edge. So you have a lot of, let's say, complexity and computing capability of the edge part with edge AI as well, with performant edges that can do with their own decision making, etc. We have decentralized networks as a trend. So you have control over certain features and certain decisions, which is spread in network in a coordinated way. Even you have you have samples where you go that far as use a blockchain or a distributed ledger technology kind of concept, fully distributed, but still fully controlled and securized. And you have, of course, an integration in the architecture from a network or let's say lower layer perspective between terrestrial and non-terrestrial. It's a core promise of 6G for global convergence and resilience. Softwareization, it's mainly about, let's say, agile, flexible network management. We have some, of course, some key trends which are, let's say, not very new, but they have been maturing in terms of their output. So you have SDN and NFV, software-defined networking and network function virtualization. So when you virtualize your, let's say, functions, you can put them on the cloud, you can offload them or unload them. You can reduce physical infrastructure dependency. So your topology, which is the logical one, doesn't have to be the same as the physical. You have a scaling of resources that is there. So with software, you can do a lot of things. You can have different, let's say, scale of acting compared to, let's say, the old classical hardware to software one-to-one mapping concept. You have, of course, virtualized, let's say, action on the radio access part, which is, of course, with Cloud RAN, vRAN. So when you decouple from hardware, you're also, let's say, more performant and more flexible than before all. And of course, the key thing for accessible use case or business case is orchestration and management for the workflows that are there. And this all, of course, helps with softwareization because the more softwareized you go, you can scale, you can replicate services, you can, in the digital, digitalization, you can control the SLA compliance, KPI assurance, etc. Okay. So then when we go to the other side, we just jump, to the other side of the SDO world, because for many people, it's like a black box. We've seen also in Jessica's presentation that some SMEs don't know even the full landscape map of SDOs, which is normal because it's very complex. So I said, let's take the megatrends that we just mentioned, and for each of these megatrends, list a couple of prominent working groups and streams or work streams that are in those SDOs, and to give a glimpse what are they doing in this respect. Okay. So if we take the first megatrend, which is AI and machine learning, We have several, these are examples, not extensive, the full list, but examples of what is going on. So you have in, let's say, 3GPP, which you all know, we have SA6, which is the working group SA6. It's working on applications of AI in mobile networks. So how to use AI to really intelligently steer your resources on your RAN part and on your bottleneck parts. And application services, I mean, this is more the basic application service type, which are, let's say, use AI and ML in order to optimize performance or to more effectively use the resources which are scarce on your mobile or radio part. Then you have the Radio X Network Working Group 3 in 3GP as well. It is more technical, more, let's say, lower layer, more hands-on in terms of optimization of the RAN. So less application service oriented, more, let's say, resource oriented. And it builds interfaces for AI-based improvements, which are then used by the SA6, which is the upper bullet point, okay? In ETSI, which is the European Telco Standard Institute, headquartered in Sophia Antipolis in France, you have ISGs, which are industry groups. They are pre-standardization, because you have in ETSI, you have TC, Technical Committee, and ISG. ISG is pre-standardization. I picked two examples. One is ENI, Experiential Network Intelligence. They look at operator experience using AI. So how can you enhance the, let's say, the resources, the behavior of an operator or service provider using AI? And they try to create a reference model or a template on how this architecture of an operator should look like to support AI mechanisms running on top of it. And they also try to define critical data sets for AI-based systems. ISG ZSM, which is Zero Touch Network Service Management, it's more about automation. So how does AI enable automation in the complex, let's say, operator landscape? There are many vendors also in the ISG, but primarily it's focused on the operator network as a reference. ITU, International Communications Union, which you all probably heard about. There is study group 13, which is called Future Networks. It looks at frameworks and protocols for using AI and ML. And you also have the focus group, SG study group. It's the standard block. Focus groups are the smaller groups which turn into SGs later, or which are for the period of time. There's a focus group on machine learning. It wants to improve and flexibility and efficiency of future networks. So FG has a limited time span. SGs are permanent and they're put in place. You also have IEEE working on AI and machine learning. You have the IEEE working group, which is the P36521. It works with a framework for standardizing applications of AI in autonomous systems, intelligent systems. You have also the Standard Association of IEEE, SA, with industry connections for networking. It's a platform for standardizing AI and machine learning and networking. So it's, let's say, building, let's say, liaisons and connections with players to really enable these mechanisms that will later maybe turn into a full standard. NGMN is the next generation mobile networks. It's the collective SDO having all operators involved there. It has a working group called AI/ML, which works on use cases for operators. Is very important. Also focus on customer experience and performance improvement. We have also a GSMA, which has a big data project to transform MNO into, let's say, AI-supported intelligent applications in business. You also have ISO IEC with the JTC SC42, which has also, I mean, ISO is more, let's say, hardcore, hands-on, widely applicable. So they have AI foundations in there, in this group, SC42, also computation approaches and system characterization. Okay? The next megatrend automation, I will maybe just cover a few, not to have the whole list. You'll have the slides, but as examples, so there's 3GP working on working group 5, which is the, or SA5, system and service aspects. They will focus on management and orchestration in that one. Also automation and network functions. So 3GP is more operator centric. So network functions are for operators quite critical, and how do you automate them is a key contribution there. Also, you have the RAN 3 group in the same respect, but going more lower layer. You have the ETSI ZSM, which you mentioned. Also, you have a group called NFV, Network Function Virtualization in ETSI. They do agile automated deployment of network services. That's their focus. You also have SG13 of ITU, which we just saw, IEEE, different working group, etc., etc. Of course, you have also, let's say, SDO like TM Forum, for example. They have a lot of standards, but that they put there. For example, you have zero-touch orchestration that they do, operation management project called Zoom, etc. Okay. Well, architectural design, you have also here the SA2, which is one of the core groups of 3GPP, which looks at network core architecture evolution. So if you look at, let's say, 5G, 6G, or 4G, 3G, it's all specified in SA2 in 3GPP, where the core logic is defined. Also, the slicing is defined there in SA2. Service-based architecture, SBA, which is the shift from 5G new radio to 5G standalone. You also have the RAN groups, RAN 2, RAN 3. In ETSI, you have the ETSI MEC, which is the multi-access edge computing. Very important because the edge is a key part in the architecture. You have the evolution of the edge towards smart and fat and capable edge. You also have, let's say, other ETSI groups, like, for example, the 5th generation fixed network, etc., etc. You have also NGMN with the project there, and GSMA. I'm covering just some key examples because it's for you to read and see if you want to allocate one where you can work with. IETF has lots of work on service-based architecture, network slicing, and security protocols. IETF primarily is more into protocols, which are, let's say, the very basic level of any contribution standards, because some standards are more complex. They have an architecture or a service that's standardized, but IETF is the one with the most building blocks, which are protocols, and you have a lot of here ongoing as a, let's say, foundation for architecture standardization. Okay. Then you have the softwareization trend, which is everything turning into software, becoming flexible, scalable in a new dimension. And you have major SDOs, of course, examples here. You have, again, ETSI, ISG, NFV, which we just covered, ZSM as well. You have we heard this in one of the presentations before, the Open Networking Foundation, ONF. So they are working on adoption of software-defined network open standards, innovation and deployment of open programmable networks. Of course, also IETF, very key thing. There are protocols and standards for interfaces in SDN, including things which you all know, like netconf and YANG. And then you have things like, which we didn't cover in the R&D community, like security privacy. So this is increasingly important. Some, let's say, example SDO work streams that are there is 3GP SA3, which is dedicated to this particular purpose, security privacy. They work on the architecture and the security aspects of the architecture, and also privacy measures, how you enable them technically in the architecture to ensure, because privacy and security, they differ quite a lot, and it's important to have, let's say, native enabled privacy through the architecture and not built on top later on. In ITUT, you have SG17, which is dedicated to security. They build trust and confidence in ICT. They look at classical cybersecurity, which is the technical security through the architecture, data protection, and privacy. And of course, you have a whole working area in IETF, which is dedicated to this, security protocols, guidelines for protocols that enable security in the architecture overall, and also, of course, security of applications. Okay. And then finally, sustainability and green communications. Standards are more and more adopting this, especially SDOs. You have an ITUT, you have SG5, which is environment, climate change, and circular economy. So they're doing standards in this respect. Energy efficiency is one of their key, let's say, driving trends. Some minor ones like e-waste reduction, etc. You have also ETSI ISG OEU, not very well known, but I hope it will be getting more traction. So you have operational energy efficiency for users. That's the name of the full name of the ISG. They look at energy efficiency in ICT. So let's say network systems, deployments, hardware, also services, know how to make service applications more energy efficient, so you can make application and software that are efficient, not use too much energy, and some of them can consume a lot. So how do you make them more, say, if you work more on the edge, you don't have a lot of, let's say, propagation, so you can be more energy efficient. So there's a lot of work there. Infrastructure efficient use and user device efficiency as well. And in GSMA, you have what we call Climate Action Task Force. It has guidelines for reduction of carbon footprint for mobile networks and promotes general sustainability in the telco part. There are studies that show that the telco and the IT sector covers between 8 to 10%, could be even more, of the overall energy consumption. So it's quite significant. That's why focusing on this is quite a key thing. And finally, to conclude, before we go to the polls, which are just very short questions, so bridging the gap between standardization and the R&D community. So the landscapes, they are both quite complex. One way to really establish like a bridging logic is to group them into megatrends, because they are to each other quite vague or like opaque community. And then after you have the megatrends, to really match them to the work streams of the SDOs, which are also the megatrends on the SDO side. And then after this is done, is to really, I did this kind of, let's say, mapping here, because I myself have been working and still working many SDOs, so I know a little bit of this. But if you are not involved in SDOs directly, it's very hard to see this landscape and to see what is the focus of each one. So then after you provide this basic mapping, you can then look one level deeper and see, okay, this is the stream that I want to go with, and this is where I could work with. Then you can team up with these different, say, communities. And this was just like a first step or like an indicative example how you can do this bridging. And there could be other ways. And I think with this, I am done with my slides. So I'd like to say thank you for this part, and I would kindly ask Claudio to load the poll questions, where we'll ask you some things or your opinion on some insights of SDOs and the like.
Okay, Muslim, thank you so much for this presentation, which was very rich and extremely didactic. This is exactly what we were looking for, so thanks a lot. I think you managed to navigate really complex landscape with, a few slides, so hopefully this will be very helpful. Also, when encapsulating all the learnings in a couple of reports, which we will publish after the event series is over. So thanks a lot. What I would do now, because we're a bit late, I would ask everybody to keep voting in the polls. I'll share the links, and I will give now the floor to Tassos, and then we can go back to the polls at the end, if you don't mind, so that we can speed things up a bit, okay? Also, based on, because there are a lot of questions to answer, I will slowly try to get people to respond to the question, and meanwhile, Tassos can start presenting, so then we can go back to the polls and comment them at the end, okay?
Thank you, perfect.
Thank you very much, Muslim, and Tassos, floor is yours. Thank you.
Yes, thank you very much. Thanks again, Claudio and Maria, for this invitation. I'm going to continue the discussion that I started in previous meeting, which is about native AI 6G architecture, so more in-depth information about the research challenges and SDO opportunities. So the first thing that we need to make a connection with respect to the previous presentation is why we need AI in telecoms. Within the UK Telecom Innovation Network, we have already identified three important pillars where AI can play important roles in networks, in telecoms, and this is also going to be a good starting point, our 6G. The first one is about on architecture and deployment, from the wireless access network to a core network to more specialized infrastructure that you will see on 5G and 6G that can be all run or multi-access edge. On horizontal, AI can be used on strategy and planning, to operation and monitoring and maintenance using network testing with AI. And finally, with respect to services and application domain, for different application scenarios from mobile to B2B, B2C services, and to enterprise and private cloud. So what we need to have a starting point with respect of use of machine learning, as we started with 5G, and we will see how this will evolve towards 6G. We started considering machine learning, first of all, on RAN to functionalities to manage challenges with respect to energy efficiency, to interference, to predict failures and outages, and finally to automate the network functions such as routing and policy. An important element, let's say, as we are moving towards in 6G, is that there are two important characteristics in networks. The first one is called self-organization. The second one is the intent-based networking, if you like to see the differences. In SOM, the objective is to automate learning, the configuration, optimization, and the healing. Where in IBM, the objective is to align network configuration and operations with respect to business intentions. Regarding the automation in SOM, we are aiming to automate network tasks, where in IBM, the aim is to have autonomous network operation based on high-level business intents and policies. Regarding the technologies deployed on SON, we consider technologies like machine learning, data analytics, network intelligence, where on IBM, it's about the translation of the intent, machine learning as well, and the closed loop operation. And why we need, what will be the benefits of such technologies? The SON is about to improve the quality of experience, the network efficiency, and to reduce the operational expenditure. Where in IBM, we are aiming to have an autonomous zero-touch network management to facilitate agile deployment and, of course, operational efficiency. When we discuss now on AI and 5G and beyond, we need to have two important pillars. The first one is the radio network, and the second one is the management and the core network. Regarding the radio network, as I mentioned, we aiming to have AI in order to optimize different functions, starting from channel state information, feedback enhancement, to the beam management and to the positioning accuracy. Now, as we already mentioned, a vital transition towards 6G is the native AI design. What does this mean? First of all, from the physical layer perspective, we need to consider a holistic design of deploying AI to the full ecosystem, from the transmitter to the channel and the receiver. We may consider a combination, for example, of a channel estimation along with a pre-coding design. And of course, it's not only about the physical, but also a MAC layer, how AI can play important role either used to random access or to spectrum sharing. Regarding the management and core, first of all, we have already seen in place functionality as part of the 5G standards. The first one is the management data analytic function, which the main emphasis is on the deployment analytic services to automate network management and orchestration. And of course, to facilitate data-driven decisions using the logic of the NSMF, which is the network slice management function, and the network slice subnet function. This is the first part. The second part is the network data analytic function, which is an analytic logical function along with the model training. What we can see as the next steps and roadmap is, for example, we can see the exposure of monitoring and status information as resource utilization to authorized third parties. to inform the AI and machine learning operation about prediction of changes in network conditions, so we can have a kind of predictive kind of behavior. How to use IBN to facilitate network slice requirements, and of course, how to optimize the network end-to-end network slicing in a multi-domain environment. If we need to see the transition to distributed intelligence, we have different techniques with respect to distributed intelligence. First of all, the first kind of transition is the parallel training, which is the partition of the data and feed the different portions to a set of distributed nodes that deploys the same machine learning model. Second option is the model splitting, which is referring to the different portions of a complex machine learning model that can be executed sequentially in different processing nodes. Another, let's say, approach is the federated learning, which is about the use of some local models that can be trained with some data. And then all this data, these local models can be aggregated by different nodes to fine-tune the model. Another important element is the explainable AI, which has been designed to explain decisions made by an AI engine. Transfer learning, which is the partition of the data and feed the different portions to a set of distributed nodes deploying the same model. And finally, distributed reinforcement learning, when different portions of a complex machine learning model can be executed sequentially in different processing nodes, and a learner can take actions over a sequence of time steps to maximize the cumulative awards received from the interaction with the environment according to a certain policy that has been adopted. I don't know now if we have time to move, let's say, to the poll, because there are a couple of questions. Probably we can do that at the end. I don't know. Claudio?
Stathis, please go ahead. Yeah, let's do it at the end. So
Yeah,
I'm sending the links to all the slides.
okay.
So we're trying to get all the votes done. Okay. Thank you. Go ahead.
A pivotal, let's say, migration and expectation regarding 6G is about the integration of terrestrial with non-terrestrial networks, and there's a lot already discussion from previous 3GPP releases. Now, there are different use case scenarios. How, for example, what will be the reason or the use case to support this integration? One use case can be or can refer to the case when the terrestrial network is not available, let's say, probably in some rural or some remote areas. In this case, the non-terrestrial network can be considered as an overlay network to provide the connectivity along with computing resources. Another use case can be to support the connectivity if there are failures or outage on a terrestrial. So there are already other, mainly 3GPP, a lot of use cases to support the terrestrial with non-terrestrial network. So some of the challenges regarding this integration, how to facilitate the environment when we can have multi-domain orchestrators. We can have the case when either the terrestrial and the non-terrestrial can be considered as a different domain managed by a different operator. How to facilitate and take into considerations the evolutions toward the virtualization technologies for edge cloud in order to optimize the AI workloads, take into account that we have an evolution in the technologies on edge cloud, moving to technologies like neural processing units that can optimize the deployment of an AI model at the hardware level. How we can facilitate the network slicing in a hybrid terrestrial and non-terrestrial network to facilitate the connectivity and to apply novel traffic policy and steering services. How to provision different net applications right in these hybrid environments, and how to cope with their resilience. That means how to facilitate, let's say, the maintenance of services like network slicing in this hybrid environment and coping with failures or with congestions. I suggest now to move to the polls because there are a couple of questions that I have already shared with Claudio. So I suggest now it's good to move to the poll session.
Okay, yes, thank you very much, Tassos, also for managing to really negotiate time and needs in that. We just basically done with Muslims part. So I think we could now go to your part. First of all, I want to show, let me show Muslims results very quickly. And so Muslim, if you want, you can try to comment on that a bit, but try to keep it quick. And then we go to the one. We get voting live, and then we will need to wrap it up. So we have 10 minutes overall, 5 minutes each. Okay, try to be brief. Perfect. Muslim, if you can. Let me share my screen now with you.
Okay. I can and I will. Yeah. Sure.
There are not too many answers because we are a bit late. I guess people are a bit tired, but nonetheless.
So let's cover them quickly. So how far do you see the work done by researchers reaching society and industry? It's very clearly on the primary stages because the answers are ranked from least advanced or disconnected to the most advanced. We can see that the majority of people see that it's on a very pre-stage disconnected. So we have no bars on the right part. You know, that's why this is a clear indication that there's a need to connect the two communities. So, yeah.
What about that? Yes. Right,
yeah. So yeah, this is fine. Next one, please, Claudio.
Also, you see, the proof of concept just got another vote, so it's still
okay. Yeah, exactly. Yeah. So this is actually it's good because you need proof of concept in the research, but then how does it connect to the real industry needs, and then how does it go to the standards? So there is still a gap there, but yeah.
Exactly, there is still a lot in between, right?
Yes, good research is in the second bar, but it needs one step to go to level 3 or 4, you know, to start to. Yeah. And then this is which SDOs do you see as most impacting in the megatrend AI and automation? So we see Etsy as a winner. I agree because 3GP is more into architectural, foundational aspects. Etsy is more from different technical engineering perspectives. IEEE is also more foundational on networking. So you know, standards in IEEE are Bluetooth, Wi-Fi is IEEE standard, or Tetra. So that's why Etsy is more the technology engineering, more engineered standards, and it's really one of the better ones for it. So it's a good answer from the audience. It's a, I would say, correct, precise answer. Next one, for architecture evolution, cognitive networks, and security and privacy. Yeah, it's kind of ITU. I agree. ITU has the more foundational standards. So does IEEE. I would say that TM Forum is more for software or higher layer architecture aspects, but for the network architecture, it's the universal standards. The most global ones are ITU. Then you have 3GP. So it's also a good answer. Quite the widespread one with all the ITU standing out. So that's fine. And yeah, it's correct. We don't see much in ISO because it's true. ISO is more into process and operational things, less into architecture. So it's a good answer. If we have the next one, please, Claudio.
Yes.
Yeah. Yeah. So the biggest obstacle, this is the interesting question, which is really very subjective. So biggest obstacle for R&D results to get into our daily lives, because as a researcher, you want your things that you do to get into real life, into society and industry. And we see that we have, let's say, two samples standing out in terms of obstacles. And this is also, I mean, for me, I think it's a good balanced answer. I'm not surprised to see this answer because if you would see only one obstacle, it would be, let's say, probably a bit maybe let's say surprising. But we see two, so it's a bit like a distributed or variated opinion there. And for me, I think it's quite a good answer.
So there is a disconnect, it appears, between stakeholders, but also the problem of trying to sort of move between the research stage to practical results, right? So the two things,
Exactly.
I think, they go hand in hand, right, in a certain sense.
Exactly, because research, you have pressure to publish a lot in research. You don't have pressure to really get your things into real life. So people say, okay, I move on to the next paper. But to incentivize how people move into the next stage to connect, this should be maybe improved. And as I said also, Claudio, that disconnect is there. We try to show some mapping, how they can get together, who can match with whom. But this is just the first step. So yeah, so very good polls. Yeah. And this was, I think, the last one.
Okay, last one. It's still not done. Please join by clicking on the link. Every link that I send is basically the same, depending on which one I present. It will change. So please go to the Menti and vote as much as you can.
Yeah.
We couldn't sort of synchronize all of them, align all of them, because
it's not easy. It's a lot of polls there also.
Yeah, exactly. There are a lot of questions, but I think these are all really relevant questions. So this is about the most effective measure to bridge research industry gap, which is, again, I think it's kind of the last, well, the Muslims, but it's a crucial one, right? Because this is about, after analyzing all the gaps and the issues, it's about what people think could be done, right? Okay, so we got the first answer, second answer.
That's a good one.
Okay.
Yeah, that's true. This is the point, because in research, there is no, let's say, connection, or there is no criteria for measurement to say that, okay, your research, your paper, your simulation, how does it relate to real life? There is no measurement, there's no incentive for that. It's true. This should also hopefully change. And also we have an outstanding, let's say, pillar, which is the validity, safety, and effectiveness of R&D results. Because if you have a result in research, people have mistrust. Will it be really in real life safe to use this kind of thing? So there is a kind of barrier for that. It's a very big winner with the 6 points. So the validation and the trust and the confidence in this research result needs to be improved to really bridge the gap. So perfect. I love this poll. Yeah, and let's move maybe to that.
Okay, great that it worked. Okay, thank you very much, Muslim. I think this wraps up pretty much with all that you had to present it, and I think it makes sense. And it's good that people are at least on the same page as far as needs and gaps are concerned. Let's go into Tasso's polls. We have still 5 minutes for that. Again, use the same link that I shared before. Please, Tassos, go ahead.
So the first question is about the type of machine learning do you foresee in ORAN evolution. So there are 5 different options: parallel training, model splitting, federated learning, transfer learning, and distributed reinforcement learning. And I can see already a vote on federated learning, or 2 votes. I'm not surprised for that, from the fact that federated learning can be very useful. So how different operators can optimize the ORAN, because they don't share the actual data, they can share the model parameters. Transfer learning as well, it's also an option how you can use transfer learning as well from different applications to optimize functionalities in ORAN. And of course, I can see also somebody has voted for distributed reinforcement learning, because it's about a stochastic environment where we use and reward based on different policies. And then the policies can be also dynamic because you may have different types of users with different types of profiles as well.
Great. Let's move to the next one. Sorry to cut.
Yes.
Again, but I think
yeah.
I think great that we're still getting a lot of participation, although
Yes.
we are 1 hour and
Yeah.
57 minutes into the event. So
Yeah.
this is great. Keep it up a bit more. Use
Yeah.
the same link that we shared before. Keep voting.
Yeah. So
Yes.
again, what kind of let's say technology, what kind of machine learning you can use in a core network? Because in a core network, the situation may be more complex. It's about being able to identify outages, failures, as well as let's say congestion. So I can see there's a lot of train towers, the distributed reinforcement learning, because this is about applying, let's say, and identify problems with the different network segments. And then through a distributed nature, you can make some reactive decisions. Again, federated learning also can be a useful approach, again, that you can have a core network data from different operators so that they can train locally. And also transfer learning for existing models from our use cases, how can move, can be applied to identify problems in the core network that can have an impact of the quality of experience. I suggest to move to the next one. So the next question is about if we like to see regarding the A native and the roadmap in different SDOs. What will be the challenge? I can see somebody has mentioned about the intent-based networking, which is basically a way how we can simplify the deployment of the networks. Of course, how to be able to provide end-to-end network slicing across different domains is a very challenging task. It's an open question, even from research towards standardized practices. I'm not surprised that the participants have selected the two options. Yeah, if we can move to the next one. The next one is about the most challenging scenario that we can consider for non-terrestrial and terrestrial network integration. I can see first of all about the rural areas, which is about supporting areas when 5G is not available at the moment. And also another option, which is a good one, is about the neutral host, giving the possibility for roaming services that can be provided to different areas. And of course, I have seen another, somebody has selected the emergency. So in the case of the disaster, the NTN can be considered as an option to provide the connectivity for the emergency response teams. So finally, what will be the challenges? All right, what will be the technical challenges for this seamless integration? I can see there's already a selection for supporting network slicing, both in the terrestrial and the non-terrestrial network. And of course, another aspect, I'm not surprised about the edge cloud, how you can use the cloud computing to provide on board in different NTN segments edge cloud services. And of course, the fact that you may have different players for this integration, and this implies also the fact that you may have different orchestrations to manage the connectivity. So at the end of the day, how these orchestrators can talk to each other in order to be able, let's say, to have an end-to-end connectivity. I try to be quick because we are running out of time. That's the end, I think.
Yes, so we concluded our polls.
Yes,
The
yes.
presentation is over. Thank you very much, Tasos. Thank you very much, Muslim, for being here. Without further ado, I would close the meeting here. I think we had a lot of good insights, a lot of participation, a lot of people coming in and getting out of this call. But overall, I think the event went well, and I really thank also the audience for bearing with us, till the very end of the presentations and participating. As said before, all the learnings will be definitely encapsulated in a final report, and then there will be a third event in the middle of May. We will announce the dates through the SNS website and also the HSbooster website, and we will also announce the program. It will see a lot more participants also from the SNS projects, hopefully, and we will present other tools, and obviously Muslim and Tasos will be there once again. So thank you everyone, and have a nice afternoon, and keep it up.
Thank you.
Guys, bye-bye.
Bye.